One.
Good afternoon. I'm Sue Rudd, Director of Network and Service Platforms at Strategy Analytics, and we have an exciting topic today, interoperable edge computing. And I've added my own subtitle of adding that service provider value to the edge cloud. And as you will know from some of the other sessions we've had on edge, there's a real challenge here of the role of the service providers versus the cloud providers, the cloud hyperscalers. So let's see what we're going to talk about. I'm going to talk about interoperability, but it really matters as to how you add value with interoperability and what kinds of interoperability it will allow you to do that. So I'm going to talk a bit about the architectures that have led us to this point, the rival architectures of telco and cloud, and what that means for edge compute interoperability. But then let's talk about where is the edge and which edges have to talk to one another and where do we put the compute and storage. And what are examples there are out there for access and edge computing, and how we have done that on a network-wide basis, which is one of the carrier advantages, being able to look beyond the data center to clouds of data centers or multi-cloud and look at where we can have interoperability on a regional, metro area, or national basis. And specifically, how to deal with some of the hyperscaler challenges with 4 use cases that I hope will demonstrate some examples that are not usually discussed of value that the service providers can add. And to conclude with why we think that leads to operability being key to the value add for network operators. So let's talk about how we got started with what became multi-access edge, but was originally mobile edge compute that ETSI initiated with several vendors originally back in about 2015-16. And what I put up here are some examples of, and I'm not going to go through all the details, but as you can see at the top left chart, the ETSI MEC started with a pretty simple architecture, the classic applications with a few silos of vertical capabilities on top of an application platform with well-defined APIs. And at the top right, you see how that started to look. And one of the early opportunities that people saw was to really look at the cloud as being an enterprise headquarters cloud, and then maybe public cloud, and then various remote access, and maybe even some other cloud access points. So we had a distributed environment where edge could then be a much lower latency or more private access. And one of the things we've heard a lot about in edge is it's all about low latency. But I'm starting to hear from operators that privacy and security, just like VPNs and SD-WAN for enterprise, are some of the biggest capabilities. And of course, proximity. Edge can be defined in terms of proximity because it's delay sensitive. So as long as I can appear to be within 1 to 10 milliseconds, I am as close as you need me to be. Bearing in mind that some routers are in fact to a 20 millisecond delay, that means a single hop often. It doesn't necessarily mean that I'm within less than 1 kilometer. I can be several kilometers away and still be very low latency. And then as you see at the bottom left, we started to look at the multiple access to virtual edge appliances. And so there are 2 aspects here. Different kinds of access technology, and that's when they eventually changed the name to multi-access edge compute. And that means that you can come in from a fixed network, a Wi-Fi network, or a mobile network, or even a cable network. And then we can see how the same virtual resources or appliances can be accessed by the different users from wherever they are. And at the bottom right, I put in one of the an early example of a fairly conventional edge platform, but looking at the functionality for control and user playing capabilities and the ability to scale a lot of virtualized server resources in real time. But we took a look at how this fit with 4G and 5G. And one of the challenges has been to fit this this, if you like, cloud architecture. Traditionally did not fit terribly well into the 4G world. And the chart at the left shows one of the early ETSI white papers on what the migration pattern for ETSI, for MEC deployments with the packet gateway and the HSS authentication, in addition to some of the attempting to do the control plane and user splits. And you can see that we get a lot of replication of the service functions being distributed across the network. And as a result, that means that the good news is that Edge lets us deploy instances of MEC apps with different HSS instantiations, or different apps with various versions of the packet gateway, and so on. So it shows the diversity that we can start to provide. And that brings in the need for a managed, orchestrated environment that allows this to be done dynamically, made private, made secure, and so on. At the bottom right, we had the convention, what I wouldn't say conventional, but what this means in terms of the basic 5G service-based architecture. And originally we were looking at MEC as sort of a parallel track, but it's become very clear that because 5G brings in this low latency capability over the air with the new radio, we are in fact looking very much at the kind of edge applications that can leverage the new radio capability, as well as the inherent security and privacy that 5G brings you. And so that is typically coming in as a user plane function, very important. The MEC should be able to support it should be able to use network-based seamless end-to-end user plane functions, whether it's through a network slice or just a standard user plane logic. And all of this under a common control plane. So using the service management function to be able to access the resources and be authenticated to have the network exposure functions that it needs. But somehow we took a detour, and I want to talk about this because this doesn't get talked about very often. About a year ago, we started to see a version coming out of ETSI MEC group that looked very different, and this came after a change in the leadership of the group. And it came due to a lot of pressure for the need to define applications and attract application developers. But it came out with a specification that was described in the February 2019 report, White Paper 2020, that was writing about the software. And as you can see, what this does, if you look at the top left, it separated the cloud and even what we call fog computing, which is the client app on the different edge that we have. Became on a UE, therefore became part of the application cloud. And so it took many functions that we are used to thinking of as part of the network functions and put them into what I will call an application layer. And what it even meant that, and this is described in the latter part of the paper, it even viewed application instantiation and mobility management for those applications and a new function called a MEC host as all being part of the application under the cloud OTT control. I was absolutely stunned when I first saw this architecture, because in fact it really is a total overlay and really didn't even leverage the authentication, validation, all of the mobility management that the service providers could bring to the game, and is probably going to actually be a very slow architecture. But it was adopted by people like MultiAccess, and they've been pioneering attempts to use it, which is okay for relatively high latency applications. But of course, that's not what we're talking about when we do Edge. That's counter to the whole intent. The good news, I'm pleased to say, is that by 2020, we come back to a reasonable approach, and we've now come back to working with 5G. And because of the service-based architecture, which we're still just beginning to deploy, but we can now look at Edge being architected around a similar structure. And there's been a recent initiative by GSMA called the Operator Platform for Edge Cloud Computing. And interestingly enough, as the theme of this session is interoperability, that's the first group that really started to call out not just PlugFest type interoperability of functionality, as shown in the Etsy PlugFest example at the left, but it really was focused around operator and domain interoperability. And one of the early applications GSMA tested that Telefonica and Deutsche Telekom then went and demonstrated in different countries was the ability to federate multiple operator platforms at the edge across a telco cloud infrastructure. And an example of part of that functionality is shown on the right. What did these rival architectures do? I think they fragmented the market. And it's interesting to see that one of the pioneers like SK Telecom didn't let this hold them up. They're very much focused on getting all this new technology, and especially a 5G technology, in 2019. And this is a chart they was put out in October of 2019, a year ago today. The SK Telecom architecture was able to define an environment with all the functions that could be purely private 5G, could be a 5G edge only, or more importantly, as you see at the top of the chart, an edge cloud, a telco edge cloud that interoperated with the center data center edge cloud and had seamless user plane functions within that cloud. And the seamlessness of the user plane functions with dynamic control and allocation of the resources is really something that will actually make edge truly more efficient if done dynamically and not in the static hierarchical fashion that the traditional hyperscaler clouds are really running a pretty hierarchical, nailed up network. And although they can virtualize servers within a data center, they have no mechanism to do distributed virtualization of the server resources across the edge or within a metro area and between clouds if there were multiple clouds. So this gets back to an architecture that we've been discussing for a while, and this is AT&T's embodiment of it. We're going to have some edge that's in the last mile. If you see on the left, we have the device or UE, which in one of the architectures we just showed is the client application edge. It can be a last mile, which is probably under 5 milliseconds. On-premise would be under 2 milliseconds as shown on the left. And then the last mile is slightly more than that, typically maybe under 3 milliseconds if you're close. The access network is going to be in between 1 and 5 milliseconds. And then the actual computing resource, which may be at what used to be a central office, but it could be in a sign next to an edge router at the bottom of a tower for mobile operators, or it could be a micro data center at the optical termination or the packet gateway. And because there's only a single hop to get to the network, this can be under 20 milliseconds. And something like 98% of applications are pretty good under 10 milliseconds, and only a very few will require the much lower level application, although I'm sure those will increase as we go forward. But so as a result, we need to really start to think about a dynamically distributed architecture. And I call this back to the 1980s. For those of us who worked with the digital equipments of the world and the early versions of HP and what became VMware, we saw a distributed environment where you could dynamically have the resources allocated across a network. And we're starting to see the emergence of what's called a mesh fabric, sometimes physical and increasingly logical, with the new Tofino P4 servers. I do apologize. I got interrupted by my alert. But what we're seeing in this distributed environment is that we're now able to dynamically assign resources, which is inherently going to make the telco server environment lower cost, faster, and more economic to the users, as well as adding, with the inherent 5G security, better privacy than is offered in the public cloud. And an interesting factor that's showing up is that the service providers, the telco service providers, are far more trusted to not exploit user information either for private or for consumer customers. But where is the key to the interoperability? And I think this is what's starting to show up, especially as we look at Release 16 management capabilities in 3GPP 5G Release 16. We're starting to see a focus on the multi-domain aspects, being able to run slices across different domains, a domain being either a transport, access, RAN, and core domains, just the logical parts of the network, but it could also be a private and public domain where I'm going from a premise to the core of the network to a cloud data center, 3 different domains, all being managed seamlessly. Or where I'm crossing Wi-Fi and fixed boundaries with something called local breakout, where I can take heavy traffic load off a mobile network backhaul and share it or put it entirely across a fixed backhaul that's adjacent via Wi-Fi connection and a packet gateway. Or for content delivery networking, video service delivery, to use multiple delivery channels and access mechanisms. And finally, to look at multi-carrier solutions like that example we had of the federated network across countries, but it can even be roaming carriers within a regional network. And over on the right, I put the examples where the cloud is really more likely to have the applications slices that we're going to see. We're going to have industrial, local, peer-to-peer video, whole bunch of application-specific cloud environments where we are truly going to see the cloud vendors potentially hosting on the telco application environments. But they present a threat. There really is not a single common interest. There is a battle for the customer, even though we're currently seeing a lot of partnerships between AWS or Microsoft Azure or even Google and IBM working with the traditional service providers to really offer them hosting so that the cloud hosting for the telco services is on their cloud. But equally, we're seeing them interested in some cases where a private enterprise asks for it in hosting on the telco cloud. But these guys are definitely expanding to the edge. And I would just mention in passing that one of the advantages the telcos have is these cloud hyperscalers really only deal in data center class environments. Their equipment is not rugged enough, does not have the power supplies and the energy supplies to be able to stand alone. And one of the advantages that the base station and RAN infrastructure can provide is they come with their own power and often a ruggedized enclosure that can support a server. But the communication suppliers have a dilemma. If they are as aggressive as the cloud guys have been, they need to pre-deploy assets at the edge and attract third parties. But if they don't pre-deploy them, they may not capture that. But they're very concerned about having stranded assets if they deploy and nobody comes, if they build and nobody comes. The advantage in pre-deploying will allow them to have a location that may not be used, but could be part of a distributed load that can be used by other adjacent users. So if they have dynamic allocation of resources, they can use even lower utilization locations. And as we mentioned, security and privacy are really critical and have traditionally been hard to monetize, but may be part of an inherent bundle that's offered by the telco hyperscalers. So let's look at 4 use cases where we see some real advantages. And I've mentioned the need for seamless user plane functions. And this is an example from Nokia, where as we see the Open RAN evolving and the ability to put user plane processing out at certainly at the centralized unit, which is a standard server, and maybe eventually at the distributed unit, where the baseband processing is done, but we certainly see the ability to add some processing intelligence, even if today it's only for authentication to block harmful traffic before it ever gets into the core of the network, or for user ad insertion can be done at the edge, but one of the other or some of the other video applications. Another one is the ability to do local breakout. It's a horrible term, but it means that I can look at that traffic I mentioned, and instead of taking it off onto the mobile backhaul network, I can break it out and send it back to a private network, which is the case shown, the HPE example on the right of the chart, or I can show it back to a Wi-Fi network, as I mentioned, for mobile backhaul to the internet. But the orchestration capability becomes really critical in this environment. One other really critical example that the Chinese have pioneered is the ability to have massive data and video for surveillance and face recognition at the edge. And this is actually an Intel chart, but it really is where you need processing right at the edge to do face recognition. And has actually allowed ZTE in China to develop their 7 nanometer chip and get some volume for that chipset. But what we're seeing is a real need to start having enormous processing power at the edge at a very low cost. But it is a good example of something where you really need it at the edge to be fast with a lot of horsepower. And finally, one that's really a core large-scale application that will come in with 5G release 16. We're going to have the ability to do 5G LANs, which is linking multiple LANs and campuses seamlessly with secure 5G, very fast, essentially 5G replacing what today may be an MPLS tunnel between campus LANs within a metro area, for instance, as well as having various kinds of roaming and being capable with fixed mobile convergence, where the service roams with the user and the user gets the same service no matter what access they're coming in from. So just to conclude, the issue is how to really leverage interoperability as a key differentiator for edge services. And while the operators need to allow for this commoditized edge cloud hosting, where either they are the commodity or they are hosting on someone else's server to get cheap hosting that they can just locate their telco services, it's important to always look at how to add value with interoperability. And I've showed the 4 use cases, but to summarize them, we need an intelligent edge that responds in less than 10 milliseconds. We need security and privacy that cloud hyperscalers will not offer because it's often regulated. And dynamic storage allocation across the metro area to utilize all our edge resources, dynamic container processor and load management, and database synchronization for all the real-time authentication to make sure bad guys don't even get into the network. It's too late if you only catch them after they've gotten in. And Wi-Fi itself requires new quality assurance and multi-domain orchestration, as Wi-Fi under release 16 becomes an inherent part of the 5G network. So we're looking at really offering a seamless user plane across all these access mechanisms. And this requires significant multi-domain orchestration and the ability to really leverage the control plane across all these different networks. So that leaves the ability for the operators to play a unique role, not just with what they call the bit pipe connectivity, but with the intelligent control, both to guarantee quality of service, resources allocation optimally across for user plane capabilities, and the control plane to offer the services on a consistent basis across multiple domains: carrier, technology, access, and even countries. And with that, food for thought, let me encourage you all to look at distributed interoperability as a key part of edge capability. Thank you very much.